Hello guys, my name is Naveed and welcome to my YouTube channel. Today we are going to solve a time series problem. We are going to predict what would be the future price of a Bitcoin. Bitcoin is a cryptocurrency everyone know. So till now, if you didn't subscribe my channel, click on subscribe button so you know everyone, because now we are going to upload the project on daily basis or day after tomorrow. So let's start with the collab.research.google.com. Now question came, why we are using collab.research.google.com? Why not on local machine, Mr. Naveed? So let me tell you. When you're going to configure project on Windows, on Mac OS, on Linux, so everyone face different errors. So we will try to best to use Google Colab. So first you need to come on collab.research.google.com, then open a new notebook, Bitcoin prediction, name it as, then connect. Third one, we need to upload bitcoin.csv. This dataset is available, link is available in description. You can go to my GitHub repo where you can find all this code and dataset. So you don't need to worry about, you need to write the code, you need to find the dataset. Don't worry about that. I have handled everything. So let's first import some libraries. Okay, first we will import some libraries. So import libraries. Make it a heading, shift enter. So first we'll import some basic libraries like pandas, numpy, matplotlib. So import pandas as pd. Then we will import numpy as np. Then we import matplotlib, import matplotlib.pyplot as plt. And to display the project in notebook and display the plot in notebook, we will use matplotlib inline, matplotlib inline. Then maybe we get some warnings, so ignore that warnings. Import warnings, then warnings dot filter warnings and pass the argument ignore. Okay, next we need to import the dataset. So import dataset, make it a heading, click on this button. Like, let's import a dataset. So make it in data is equal to pd dot read underscore csv, and the name of dataset file is bitcoin dot csv. Header is equal to no header. Okay, then data dot head, shift enter. So now we don't have the, you can say, column name. So let's give the column names. Data dot clumns, data columns is equal to th months, and then next is price. Now let's look to our data. So here you can say month and price. Now our month is in this form 0 1 2. We have datasets starting from 2018 to 2020, so we need to convert these things from numbers into the date format. So let's do that. So let's import some you can say the libraries that related to date time. So from date time import date. Then we will import relative delta. So from date util dot relative delta import relative delta. Then we will run the for loop on the all the dates that we have. So for I in range start from 0 to the length of you can say our dates we have. So data dot months column and data dot months I. So now we are going to update each value. Now we are going to update this one, this one, this one. So I will, you can say, therefore we run the for loop. So first one 0 1 2 3, and then we are going to update all these values is equal to So start from date 2018 comma 1 comma 1. Then we will add relative delta. Relative delta, so that is the months plus 1 plus, you can say, the I, plus is equal to I. Now let's look to our data dot head, shift enter. You say like is, no sorry, equal to this one. Okay, now we have convert dataset from this format to this date format. Sorry. Okay, now next thing is we need to set the index as a month column, our data frame. So data is equal to data dot set underscore index and months, and data dot head, shift enter. Okay, so now we have set the index, so we have removed this column. Okay, now we are just going to visualize our dataset, and then we will apply simple model moving average. So first we will apply the naive Bayes, not naive Bayes, sorry, simple naive method, a very constant value. We say just a random value like 25 is a prediction, like very naive you can say model. Then we will apply moving average, simple moving average 12, 6, 3, moving average, and then we will compare the results, which results are better. So moving average, just to, if you want to see the trends in your dataset, then moving average is, you can say, one of the first option that we can explore. So let's you can say visualize our dataset. Data visualization. So simply data dot plot, we are going to plot our data frame, and figure size that we are going to apply, fig size is equal to 20 by 4. But that will you can say simply plot a simple line chart. But now I also want a grid at the background, so let's also give the name to our chart. So for that we will use the plt. So plt dot grid, then plt dot legend, and simply this is going to set the location is best, means like location of a left of our chart is on upper left, so that is a by default value. Simply plt dot title, give title to our, you can say, chart, that is price Bitcoin price, and then simply plt dot show. Now let's see, you can see like Bitcoin price is a title, price is, so this is our price from in 2018 and then 2020 in September. So now we are going to split our dataset into training and testing, and then we will apply all the methods that we have discussed. So we will divide, take the 29 you can say the rows as a training and rest of a testing. Then you ask question, Mr. Naveed, why 29? So this is a random value that we are going to take all that, you can split into 80-20, 70-30, no problem. So training dataset length is equal to, you can say, 29, and then train is equal to data 0 to train underscore length, and test is equal to data train underscore length to at the end. So this, now we have split the dataset. Now let's apply the naive method. Naive method, you can say any constant value of our prediction, so we will use the last value for the prediction. So let's apply the naive method. Naive method is means simple method. You are just going to give any constant value as a, you can say, this is a prediction of model. So y underscore hat underscore naive method is equal to, let's make a copy of our test dataset, test dot copy, and in our y hat underscore naive data frame we make a one more column that would be the naive forecast, and that would be the naive underscore forecast, that would be equal to last value from the train data set, train data frame, train price and train underscore length -1, shift enter. Okay, now we will realize our data set, so we can reuse this code that we use above, or we can write this one. And first we will write the code for name method, then we will reuse this code for, you can say, other method like evaluating the evaluation matrix. We will reuse the code for the realization, we will reuse that code. So for first one we will, you can say, the write the code. So plt.figure, like figure size would be, fig size is equal to 20 by 5. Then we are going to plot the grid. So now in this grid we are going to plot different lines, like that was the training price, testing price, prediction, like forecasting. So we are going to plot different, like plt.plot. So let's first plot train and price, and its label would be train. Shift home, control C, enter, shift control V, and that would be the test, and here we will change test. Same, shift home, control C, and then we are going to, here we are going this one, use this one column that we made here we paste this one, and this is the naive forecast, and naive, naive forecast, for naive forecast. Then simply set the location of our chart, log best, and give it the title plt.title title, and naive naive method, and simply plt.plot, shift enter. So here you can see this blue line is a training dataset, training price, orange line is testing, and this green line is a naive forecast. Why this is the horizontal line? Because this is a single value. Let me show you if you wanna see. Control C, code, shift enter. So this is the 2,191 pound, or you can say dollar, is a constant price for each test data. So therefore we are getting the horizontal line. So now we are just going to calculate some evaluation metrics for our this naive method, and then we will use moving average method. From sklearn dot matrix import mean square error. So first of all, root mean square error. Root mean square error simply is the square root of mean square error, is equal to np dot, and we have the, you can say, the formula of mean absolute percentage error, root mean square error. So simply we can copy that, and here we can paste, so just to save the time. So here you can see root mean square error simply the square root of mean squared error, and just you need to provide, this is the original price, this is a prediction. Then for mean absolute percentage error, so first take the error, then absolute means negative, positive, same, then you need to round that and take the mean, and then we will make a round, and we say okay, we only need 2 points after decimal. Then we are just going to make a data frame. I say method, column name, value, name method, column name, value, root mean square error, value, and these are the results, and shift enter. So here are our results. Okay, now we will use the moving average method. So first we will use the simple moving average method, then moving average 12, then 6, and then 3. Simple moving average method. Simple moving average method, just think like first you need a constant value. First you just take a constant value and you say this is a prediction. Now you just going to take a mean of a price, and then you of you can say testing data frame price, and you say okay, this is a prediction. So don't worry about that like moving average method is a very big thing. No, this is a very simple thing just to analyze the, you just see the wanna see the trends, and then we have moving average window 3, 12, 6, 3, and that is a thing. So don't need to worry about that like this is a very difficult thing. No, this is a very easy thing. Simple moving average is simple mean, no problem. So let's start with that. So same thing, I will copy that this code, so it will make you more, you can say, confident and more feel comfort like this is not a very, you can say, different thing that we are going to do. So before that, here we take a constant value, but now what we are going to do, we are simply we are going to take the average of this price column, and that's why we are saying, going to say this is a prediction. That's it. Dot mean and average forecast, average underscore forecast, shift enter. Then again we are going to visualize. So simply we can reuse this code, control C, control V. So we say here simply this is the price, same test, same, then y hat nav average forecast. Simply change this one, and label is simple moving average. Then copy this one, control C, control V, shift enter. So why I am copy and paste the same code, because just to make you feel comfortable. Okay, like Mr. Naveed is not going to do any extraordinary thing. No, just simply we are going to change like constant value to the mean, and we say this is a simple moving average. That's it. Next we are going to, you can say, evaluate some evaluation metrics. So for that we are just going to copy this one and change some, control V, like actual price, average forecast, actual price, average forecast. So and formula is same for root mean square error, and sorry, y hat, its name is y hat average, y hat average, shift enter. And here we also need to update y hat average, shift enter. And simply this is the original price, this is the prediction. And what is the prediction? Simply mean. So here this, the green line is the prediction. So this is simply the mean of this, you can say, the price, average of price, if you think like mean is some different thing. So simple moving average, root mean square error this, mean absolute percentage error this. Then now we are going to use some, can say, simple moving average method 12 means now we are going to increase our window. First we say like only 1.1 mean value. Now we are going to increase our window to 12, then decrease 6, then decrease 3. Simple moving average method 12. What is 12? Simply we are going to increase our window. There is nothing different. So simply y hat simple moving average, we are going to copy our data. So this is original data. So what is moving average window? That is our 12 size. Okay, then y hat simple moving average forecast is data price, and then I am using this function rolling. So now what is the difference? Only we are going to this function, rolling function, and we are going to provide okay 12. So we have the window of 12 size. If we have a 6, simply update here 6. If we have 3, simply update 3. Otherwise same code that we used the previous. Control Z and shift enter. Now say we can same reuse the code of the, you can say, for the graph visualization. And here you can see this blue line is a training data set, orange line is the testing data set, and this green line is simple moving average. So now you can see this moving average is, you can say, just, you can say, we are analyzing. This is just going to, copy some pattern of a data set. So next we will simply calculate some matrix. So simply we are again reusing the code that we use for the simple moving average. So this is the root mean square error, this is mean absolute percentage error. And don't worry, at the end we will compare all these moving average method. Then we now will use simple moving average method 6. So all would be code would be same. What we are going to change, simply here we are going to write 6. Simple moving average 6, make it heading, shift enter. So simply we just change here from 12 to 6. That's it. Then same code for visualization. Then same code for evaluation matrix. So this is a mean absolute percentage error. And at the last we will use the simple moving average 3, and then we will analyze all average method, moving average method. Make it a heading, shift enter. So we just need to we are just change this from 6 to 3. Then we are going to plot. And here you can see this blue line is, you can say, training data set, green line is the simple moving average forecast 3 month, and this orange line is our testing data set. And let's calculate evaluation matrix. Why I am simple copy paste the code? So just to make you feel comfortable. Otherwise for me, I can write the code and this would be the very long video for 1 hour, for 2 hour or 3 hour. So for me, main purpose is to just to make you clear, like moving average method is very easy, just piece of a cake for you, like other machine learning algorithms. So now we are just going to analyze all moving average methods. Analyze all moving average methods. Make it a heading, shift enter, control C, and that's it. Simply we just make a data copy, and we are just going to make an data frame that is just going to tell you, okay, with simple moving average this was the you can say evaluation matrix and which one was the best. And let's take a look at the top 20 rows. So against each month, this is the price, and simple moving average forecast 12. Okay, for this, not a number, not a number, not a number, and this one we have 217.4. okay, and this is the thing, like simply we analyze all moving average method in one row. So that's it for today, and I am just trying to, you can say, to avoid a very long video. That's it for today. If you like my video, click on subscribe button, hit the bell icon, and let's meet another video.